So I'm going to go ahead and take a look at the homework that you turned in last week, just to kind of make sure that we feel totally comfortable with this as we move into finals in a couple of weeks. So where in the graph is the object moving most slowly? Remember, steep means fast and flat means slow. Don't look at a whole region, just look at the actual point, and we realize that if we look only at the point, it's at points B and F. Now, between which points is the object speeding up? Well, remember, speeding up means going from flat to steep, and that can mean going forwards or backwards, so this would also qualify. So let's see where that's happening. From B to C, we're going from flat to steep. From F to G, let's see, no, yes, no. That's it. All right, and the reason we can say this is we go from flat to steep slope. Now, it's the exact reverse for part C. We need to go from steep to flat, or like this. So what that means is going from A to B, also from E to F. And what this means for us, why do we know this? Because we go from flat to steep slope. Now, where are we changing direction? What does it mean to change direction? This is positive slope, and this is negative slope, and that's the algebra that we need to know. Now, what this means in real life is this is going forwards, and this is going backwards. So we need a point, we need a place where we see us going from forwards to backwards. So that happens at point B and at point F. Because we go from positive slope forward to negative slope, which is backwards. And that's how we do that. All right, so that is page 1 on the homework. Taking a look at page 2, if we wanted to give a written description of the motion, I'm going to try to type this. It's really obnoxious because the keys get really loud here. So if we give a written description of the motion, what's happening is we are going backwards with increasing speed from -3 meters per second to -9 meters per second. Now it says how far did it go from 0 to 4 seconds? We're going to use the area formula. And I'm going to use the area of a trapezoid, though you can use two triangles. So the area is given by 1/2 base times h1 plus h2. The base here is going to be 4, that's the seconds part. And then the height is going to be from 3, that's this height, and then this height here is 6. So we end up getting 2 times 18, which is 36 meters. That's how far it went. That's the distance. Let's be clear though, -36 meters would be the displacement. Okay. And then how far did it go from 4 to 8 seconds? Let's do just kind of a similar idea here. So this is -9, this is -6. So the area is 1/2 of the base, which is 4, times 6 times 9, which is 2 times 54, which is 108 meters. Again, the displacement would be -108. Whoops. Because we actually care about direction when we calculate displacement. But this is the answer that they want here. And for B, that's the answer that they want. Now it says determine the acceleration of the object's motion. So the acceleration is the slope of the velocity graph. So I'm just going to do a rise over run calculation. So I've got -9 minus -3 over 8 minus 0. So that's going to be -6 over 8, which is -0.75 meters per second. Now, a possible x versus t graph, well, one thing is that we need a non-zero slope because we're going backwards. So I do need to start off with kind of a negative slope like that, and it's gaining speed, so we're going to see a graph like this. Okay, and it should be a curve. I'll just stretch this out a little. This is something we can do on. That's a little bit better. Now, another thing we can say is this is one possible graph, okay? The reason we have other possible graphs, and again, this is the graph for speeding up, going backwards. Why is this one of many graphs? So this is our initial position. We have many possible initial positions, not just what we have here. So, use a kinematics equation to solve for the acceleration. Let's try this one. V equals at plus v naught. Our final v from the graph is -9. Our initial v is -3. The time elapsed is 8. And a is the unknown, so we can say -9 is a times t minus 3. We're going to end up getting -6 equals a times, and the t was 8. Sorry, I didn't plug that in there. And so a is -6 over 8, -3/4. But we want to see that written as -0.75 meters per second squared. So that's the problem right there with using graphs. And we're not going to do motion maps in this class, so I'm really sorry I included that. We definitely don't want that there. So it says give a written description of the motion. So the way I would write that is I would say the following. The object is going backwards at a steady 4 meters per second. It then slows down to stop and slows down to stop and turns around at 4 seconds to gain speed going forward. All right, so now let's just see. That's good. So with this here, to get the displacement, we'll actually get the area from 0 to 4 seconds. I'm going to actually go ahead here and do this as a square and a triangle. So from 0 to 4 seconds, that's going to be 1/2. So it's going to be the square plus the triangle, which is going to be 1/2. Sorry, it's going to be 2 here times -4 here plus 1/2 times this base, which is 2, times the height, which is -4. So I'm getting -8 plus -4, which is -12 meters. Now the displacement from 4 to 8 seconds, it's a triangle. That's going to be 1/2. The base is from 4 to 8, so that's 8 minus 4, which is 4. Okay, so the base here is 8 minus 4, which is 4. And the height, let's be really careful. Going from 4 to 8 seconds, my height is 8. So I'm getting 2 times 8, which is 16 meters. Now it says get the displacement from 2 to 6 seconds. So I'm going to actually eyeball this. I have an upside down triangle that has this area. and a right side up triangle that has this area, and they're equal areas of positive and negative area, so this equals 0. The acceleration at 4 seconds, that's a is delta v over delta t, and that's going to be 0 minus negative 4 over, because I'm using this from here to here, my over 4 minus 2, and that's giving me 2 meters per second squared. And now a possible x versus t graph, I would go forwards like this, backwards like this for a couple seconds, and then I'm going to continue going backwards. I'm going to make this a little bit steeper. So I'm going to go backwards like this, and then my speed is going to level off to 0. And then I'm going to start going forwards, gaining speed the whole time. So this is here what's happening until 2 seconds, then 4 seconds, and then I'm at 8 seconds here. This is a bit of an advanced topic, and I do not plan on making you go from V to X graphs, so I'm just going to say not on your final. Okay, and this is kind of the value in me going back and doing older homeworks, just to kind of clear up things that you are and are not responsible for. All right, now for problems 8, 10, and 12, I'll tell you what. These are a repeat of other problems, and I'm going to put up solutions, but I'm going to hold off on doing videos for these homeworks unless people specifically request it. So I'm going to work out PDF solutions, but I'm not going to post the rest of the videos for this because I have other things that I need to attend to make sure that we're having a good class next week.